Hello, my name's Kate Warner. I'm one of the data managers for. My name's Kate Warner. I'm one of the data managers for GlyGen. Today, I'm going to be talking about our sustainable knowledge bases, what we've implemented, and what we plan to implement in the future. I'm going to start with a bit of background because it's important to understand our data infrastructure, and then I'll talk about some of our sustainability strategies. So, the GlyGen knowledge base, if you don't know, collects glycomic, glycoconjugate and proteomic data from different resources. We then homogenize, standardize that data, make it available in different formats. We check the consistency of those data sets, do some quality control, and then integrate that data into one resource. So if you're interested in glycans, glycosylated proteins, this is the resource to go to first. And so as it's already been discussed, usability is incredibly important for sustainability. It helps you get funding, it helps your discoverability, it helps you to grow and innovate. So we have many different types of users, and so we have many different ways for those users to access GlyGen. We have a web portal, a data portal, an API, wiki for documentation, and Sparkle. Also, something I should have added here were databases, actually. We work very closely with lots of databases. We allow them to use our data for their own purposes. And of course, we innovate. So we're actually thinking about providing new interfaces so that AI agents can access our data. So when we were thinking about this presentation, our team, we thought, how do we describe if is our infrastructure sustainable? So what would happen? So we wanted to think of an incredibly extreme example. What would happen if GlyGen, if the entire team suddenly left and there was no one to run GlyGen? And rather than thinking about, oh, our funding went and we had to shut down because that's pessimistic, we're going to be really optimistic. We're going to say, we all won £1 million and we left GlyGen to somebody else. So could somebody come in? Could another team? Could the remaining team member that didn't have the $1 million run the knowledge base, support our users, and even recreate GlyGen or parts of GlyGen on their own server? So one of our sustainability strategies is through our technology stack. So what we try to do is to make our entire data infrastructure sustainable. So this is our data, the GlyGen pipeline. If you're interested in our data model and our data processing workflow, there's a link to our paper. And so what our aim is to make all individual components of the GlyGen pipeline, the source, open source code, which is containerized on Docker Hub. So it's automated. And what this means is that it can be initiated by anyone. And this is in the entire pipeline. So even starting with the source input for our data, we try to use the main resources that we use, things like Uniprot, Ensemble, GlyToucans, PubChem, Kebi. All of those resources that we use are freely available. So anyone can get most of the data that we use to create our data sets. For dataset creation, so our source codes for data extraction and standardization is already available on GitHub for anyone to use and utilize and adapt to their own needs. And of course, in the future, we plan to containerize this, make it available on Docker Hub, so it's even more automated. So someone like myself, who's not a programmer, can actually run it. Also, in addition, each data set has a biocompute object, a BCO, which is available at data.glygen.org along with the data set. So if you're unfamiliar with biocompute objects, what these are kind of like a README file for any bioinformatic workflow or analysis. So the purpose of it is to show how a bioinformatic analysis was done so that people can look at the BCO and they can reproduce it with their own data. So in regards to the GlyGen databases, data sets, each one of these has a BCO. And what this does is it provides detailed documentation on how that data set was created, from what the source input was through to what code we used to produce the data set, right through to the output. So what was the resulting data set? And what this means is that in theory, if GlyGen was to go down completely, these BCOs are on biocompute.org and people can go there look at how we created that data set and reproduce it for themselves. So it's a great way for data sharing and reproducibility. Anyone can produce a BCO. They're available. It will give you a ID that you can then use in papers and things like that. So please do go ahead and check out biocompute.org. And of course, for another part of our data setting creation protocol is we utilize standardization, and existing ontologies, which has already been mentioned, is incredibly important for reuse and interoperability. So for dataset integration, again, all of our current GlyGen datasets for each release is actually available on data.glygen.org. So if someone just wanted to sort of create an archive version of GlyGen that doesn't change, isn't updated, they could download this entire data set and use it for their own, in their own servers to display that information for our poor users that no longer have access to GlyGen. As for creating new GlyGen datasets, so these are any new information that's coming from our data sources. We're currently generating an integration open source code that will be available on GitHub and will be containerized. So once these are CSV data sets, once these are produced, we actually process them further into JSON objects and RDF triples, and these populate the backend databases. So that's our Virtuoso triple store and our MongoDB doc store. And the source code for that is on GitHub, so anybody wanting to produce their own can use those. Also, of course, Virtuoso and MongoDB softwares are available for anyone to use. If you wanted to completely not change the infrastructure of the GlyGen infrastructure, you could download that, put that on your server, and it would work in theory. Also, all current RDF triples are in the triple GlyGen that are in the GlyGen triple store are available for download at sparkle.glygen.org. And then, of course, the resulting data access mechanism. So GlyGen portal, the API and front-end source codes are available on GitHub again, and we have documented APIs which are publicly available. So that was technology stacks. And these are our data spaces, which I've already mentioned. This is another way that we try to maintain sustainability. So GlyGen data access mechanisms are they're related, but they're completely independent. And what this means is that it's very easy for us as a team to maintain and innovate these different domains. But what it also means that if somebody wanted to, they could take parts of that infrastructure for their own means. So if they just wanted to reproduce part of GlyGen, or if they just wanted to use our portal infrastructure to create their own portal. So a use case example is Biomarker KB. So this is a project that's part of the Hive Lab. GlyGen is also part of the Hive Lab. And the aim was to organize and integrate biomarker data from different public sources into a single knowledge base. So we had all of these biomarker data sets as CSV files. And what our front-end developer, Sujit, did is he took the GlyGen source code. We only wanted the web portal and the API, but he used that to quickly redeploy the biomarker KB portal and make it available for users to use very quickly. And without him having to re-implement anything or write any more code. And the outcome of that can be seen at biomarkerkb.org. Other sustainability strategies, of course, it's reuse and usability is incredibly important. So we think that by having this open license, making it freely accessible, it means that anyone can use our data. We encourage fair data and open science and collaboration. So anyone can come in and use our data for their own databases or for their own analysis, but of course, always try and cite us. It's great for funding. We also make use of standards and ontologies, which other people have been speaking about in the other sessions, which is, of course, is important as well. It improves interoperability between databases. It allows people to understand and link and consume our data. So, for example, we use glytoucan IDs for glycans, uniproteases for proteins, and for disease information, we provide disease ontologies and many, many other ontologies that we're continuously updating and incorporating into GlyGen. And of course, another important way is kind of like a data preservation through collaboration. So we're part of GlySpace Alliance, along with GlycoXBase and GlyCosmos. We share information on the glycobiology domain, and we work collaboratively to sort of meet the needs of the glycobiology community. And what this means is that we can all develop unique tools, unique ways of looking at glycobiology without duplicating our efforts, allowing us to innovate independently and improve what's available for our users. Also, if, heaven forbid, GlyGen was to suddenly shut down, some of the tools and some of the data will actually migrate to these other databases so that it's there, it's available, our users can still find it. And of course, we're part of the Common Fund data ecosystem, which promotes interoperability and usability and visibility. And so this greatly helps with sustainability, greatly helps with funding, etc. And also, in theory, they have our metadata, and we have an open public license. So somebody, a member of the CFD, could actually continue with the project, GlyGen project, if everyone was to suddenly disappear. So to summarize, our sustainability strategy, so our sustainability technology stacks and our data access mechanisms are very independent. They could be operated, innovated independently. We have open licensing standards and ontologies, allowing other people to consume our data. And of course, we have collaborations for data conservation. But of course, everything has a shelf life. So funding goes, we could automate the entire pipeline. We could have one person running it without updating anything, but things happen, things break. There's a new software update. The resources that we download change their formatting, and that will lead to the integration pipeline sort of shutting down. So it's been really interesting hearing from other people talking about what strategies they'd adopted, and it'd be interesting to discuss with anyone anything that they might suggest to improve our sustainability. This is the GlyGen team. Our PIs are Raja Mazumba and Michael T. Meyer. I'd like to thank Renee, Jeet and Unisha, who really helped put this talk together, and of course our collaborators at ECCB, NIH and the GlySpace Alliance, and thank our funders. And thank you to everyone for listening. And there's a link there to glygen.org and to our source code if you want to take a look. And thank you very much.
Thank you very much, Kate. A terrifying commitment to sustainability, which makes me believe you're buying a lot of lottery tickets. Do we have any questions from the audience?
I've looked at the biocompute objects, but not in any depth, and I wondered how heavy of a lift was that?
It's pretty, so it might not be very visible, but they're pretty easy to put together. I haven't put it on this slide, but so for the data sets, it's pretty much we put in the contributors. We have a short description on the data set. We put a link to GlyGen to show where our source code is, and then we give information on like the species and things like that. So ever since I've been here, ever since I've been working at GlyGen, we've always created a BCO for each data set, and it's just super easy. If one of our collaborators wants to know that how a data set that they want to use is generated, we can give it to them, and they can generate it themselves if they wanted to. You know, we really encourage people to use our data for whatever means, but cite us and acknowledge. Yeah.
Hi, thank you for the talk. You mentioned in the beginning that every data set that is uploaded is checked and there's some sort of validation. To what level this validation is done? For someone who's interested in looking for glycosylation in vivo and in vitro using mass spec, for example, we need some glycan libraries, but there's an issue with some of these, the glycans not being really experimentally validated. So that's something that is to level of confidence that we have in the data.
Yeah, we have many glycan experts working for our database that check our data. And then, of course, we have people like myself, that's my main job. I check the protein data sets, and the other data manager, Nisha, checks the GlyGen data sets, as well as other people checking the data sets as well. And then we have scripts that we run to check that, because sometimes some people will say that maybe an N-glycan is attached to the wrong site. So we have steps that go through and chuck out those incorrect assignments. It's not always perfect. There'll always be mistakes, because the database is growing and growing and growing, so it's difficult to check every data set. But if you're interested in GlyGens, if you go to our GlyGen pages, we have publications. We have publication pages which will mention all the GlyGens, all the proteins that we use, and all the data we've extracted. So you could actually be confident, because there's a paper, that information is correct. Yeah. But please do feedback. If you see a mistake, feedback. That's really important as well. As part of our sustainability, people feedback mistakes and we correct them very quickly. So we have a GitHub repository. It immediately comes into our GitHub issues and we respond immediately.
Thank you.
So I have a question. So apart from your own primary data and maybe your direct partners, the three-way partnership you talked about, you have a lot of dependencies on other database providers and other database releases.
Yeah, definitely.
Does that generate issues for you? Is there anything there you wish would be done next?
Yeah, I mean, we work very, very closely with Uniprot, because that's where we get our proteomic data. So we actually have a GlyGen developer that works at Uniprot with Maria. So yeah, any changes we can see pretty quickly in our data, and it can affect it. And sometimes there's a bit of a difference between, so I can only look at the website and what it shows, but like Uniprot is providing us with new data, which is not on their website yet. So sometimes it's difficult to look between, well, is that information correct? Because on Uniprot it's saying this, but the new release is saying something else. But then of course we've got that developer who can look at the most current releases and work it out. But a lot of my role is looking at why suddenly something like BG has dropped a load of cross-references. So I'll look into that and make sure, so that's a big part of what I do, make sure that drop makes sense. And if not, we feed it back. Of course, we work collaboratively with them. So we feed it back to them and say, well, why is all of these IDs you had in your last release now missing?
So there's no automatic magic solution. You build the personal relationships.
I think having the close relationship with Uniprot is really important, and it really helps. And of course, we can prepare our releases together, which is really helpful. And having that, we like, rather than speaking to someone through a help desk, we like having an email of that person who works in that area. That's really nice. It's really nice to know who is the person that does this, so that we can interact with them. And we have lots of virtual meetings and things like that to sort of really establish those close collaborations to improve our data, not just in our database, but in their database as well, because they might not these databases are so huge, they might not realize that a load of data in their next release, because the number of times we've run a release and a data set disappears for no reason. It's the same script we ran last week, but this week it's decided it doesn't want to work. And it's important to, I think, feed it back to them and to work very closely with them.
Okay. Thank you. Yeah. Right. Thank you very much, Kate. And now over to